tools and techniques.
This call is now being recorded.
For solving real-world problems in the field of electrical engineering, which is organized by IEEE Bombay section in association with Department of Electrical Engineering of P.R. Pote Patil Educational and Welfare Trust, College of Engineering and Management, Amravati, in collaboration with Department of Electrical Engineering, St. Vincent Pallotti College of Engineering and Technology, Nagpur. I welcome Chairman of our institute, Shri Praveen Bhau Pote sir, and Vice Chairman, Shri Shreyas Kumar Pote sir. I welcome Honorable Dr. D.T. Ingole sir, Principal of P.R. Pote Patil College of Engineering and Management. I welcome Honorable Dr. Muhammad Zuhair sir, Vice Principal of PRPCM. Now, I warmly welcome our today's resource person, Honorable Dr. Kailash Chand Sharma sir, Assistant Professor in Department of Electrical Engineering at Dr. B.R. Ambedkar National Institute of Technology, Jalandhar, Punjab. Welcome, sir. I welcome Professor D.A. Shahakar sir, HOD of Electrical Engineering Department, PRPCM. I welcome STTP Coordinator Dr. A.S. Selang Madam and Professor G.S. Gadge sir. I welcome all the HODs of respective department, faculty members and participants from other colleges. Now, it's time to introduce our today's resource person. Today, we are very fortunate to have eminent personality Dr. Kailash Chand Sharma sir with us. Dr. Kailash Chand Sharma sir has received his PhD degree in electrical engineering and MTech degree in power system from Malviya National Institute of Technology, Jaipur. He has completed his BE in electrical engineering from University of Rajasthan, Jaipur. Sir's area of interest and research are power system economics, power system operation, electricity market, forecasting and optimization. Sir has received award for outstanding MTech thesis work on wind power trading in competitive electricity market. This award is given by Power System Operation Corporation and Foundation for Innovation and Technology Transfer, IIT Delhi in 2013. Sir has publications in various international journals and international national conferences. Sir has total 312 citations and H index of 08, I-10 index of 08. Sir has guided 3 research projects, out of them 1 research project submitted and 2 are ongoing. He has coordinated 2 one-week TEQIP sponsored short-term courses. One is Operation and Control of Next Generation Low Carbon Power System and Recent Trends on Renewable Energy Systems and Their Control. Also, coordinator of 1 week FDP on recent trends in industrial automation. He has participated and attended various seminars, workshops, short-term courses and conferences. Sir has delivered various lectures on general algebraic modeling system in various technical institutions. Sir has handled various departmental responsibilities. Also, Sir has handled various professional activities. He is a senior member of IEEE USA, life member of IST. He is a member of International Society of Energy and Built Environment. He is a reviewer of IEEE transactions on power system. Sir is a reviewer of IEEE transaction on sustainable energy, electrical power components and system, international transaction on electrical energy system, IEEE transactions on industrial informatics, technology and economics of smart grid and sustainable energy. And also, he is a reviewer of applied energy elsewhere. So, we all are very eager to listen Dr. Kailash Chand Sharma sir, who is going to deliver presentation on Introduction on Power System Modeling using General Algebraic Modeling System and PSSE platforms. So, I request Dr. Kailash Chand Sharma sir to start the session. Please, sir.
Uh, Thank you, Mrs. Smita, for a nice introduction. Am I audible?
Yes, sir.
Okay. Uh, just I save my screen. Uh, yes, my screen is visible.
Yes, sir.
Uh, okay, so thank you very much for the introduction again. And first of all, I would like to thank the organizers, especially Dr. Aparna, for inviting me. And I also thank you for the PSSE Institute and their management and their academic department organizes this type of the social courses. Now today, there are two parts. First, I discuss the fundamental of the GAMS, that is General Algebraic Modeling System platform, and the next half I discuss the another platform, that is the R, because I yesterday I faced some technical difficulty with the PSSE, so no continue that software. I am instead to the PSSE I discuss the R modeling used in the electrical engineering. So let me start with our first topic, introduction of the general algebraic modeling system. As you know, in a power system, there are so many optimization problems. There are in prospective to operation purpose and also the planning purpose. And optimization not using the
No,
power
sir,
system.
your presentation screen is not visible.
My side is visible. Just a minute. Now visible. My screen is visible.
Uh, no. What?
Any other participant? I think so.
No, sir, it is not visible. And your voice is also not clear, sir.
Okay. Uh, but it is visible for other participants.
Yes, now it's visible.
I think you have some internet issue at your side, maybe. Okay, shall I continue?
Yes, sir.
Okay, so optimization is very active area of the research in the engineering, mathematics, science, and any other fields. And we are formulating the real world problem in optimization framework that have some objective function and some constraint. Then we are trying to solve that problem by using some conventional method and some advanced like a heuristic methods nowadays people are using. So instead of like we are looking forward, looking and we are working on the solution part or some algorithms. Now we can use like tool like the GMS to solve the any optimization problem and get the solution. So by using this type of the tool or the platform, we are more focused on the modeling part rather than developing a solution or like a solution algorithms. So this is the software that can solve any type of the optimization problem. That is very different. That is vast variety, and it's very easy to use. So researcher and the people can more focus on the modeling part instead of the solution part. Now we know these are the some problem in the power system operation and the planning problem. The most important problem is a very convenient, that is generation scheduling, that including the economic dispatch, security consent for dispatch, unit commitment, power flow, optimal power flow, hydrothermal scheduling, hydro operation of nowadays energy storage, electric vehicles. In market perspective, the bidding strategy for the distribution network, the reconfiguration, congestion management, demand side management. So these are the some problem. Operation means their time horizon is the last. For like they had mostly the day had problems, and planning problem their horizon is a long time. There may be some months and some years. So these are the
Hello.
yes.
Hello, sir. Same problem.
Uh,
Three.
am I not audible?
Maybe WhatsApp screen is open.
No. Now it is. Is it fine?
No, sir. Please open Google Meet.
Okay, I'll leave and join again.
Good morning, participants. Sir may be having some network issue. Let's have some patience. He will be joining soon.
Okay, ma'am.
Yes. Now, is it visible?
Yes, sir. Yes,
Okay.
it's visible.
Okay. Okay. Fine. So these are the some important operation planning problem that we can optimize and solve by the various methodologies. Now these are the some techniques, conventional techniques, and some heuristic technique. I won't go into the detail. And yeah, that we explain the general procedure to solve real world optimization problem. Real world means the like our power system problem or any other problem. So first of all, we have to just understand what is the problem. Then we formulate the problem in a we maximize this solution. Then we define the constraint. Then we define the variables. So we have to develop a mathematical model. Then we solve this mathematical model by using the any optimization technique. So here we are using by using the solvers. Solver is nothing but they are some like a built tools, or they are like algorithms or software. They are designed, they are developed to solve the particular type of the problem. Then by using the solver, games have the variety of the problem solver. Then by using the solvers, we get a solution, and we also check this one. This is the our desired solution optimal. So if there is any problem, like problem sometimes is visible, unable to give any solution, then again we check our mathematical model, and again we repeat this procedure until we get optimal solution. So this is the general procedure to solve any problem. Now there are to solve any optimization problem. There are multiple algebraically oriented modeling languages. They are
Excuse me, sir. There are
yes.
some background sound. They are not here to listen. Something is
There is no background.
some sound is
Hello.
coming from background.
Now is okay.
Not
Okay.
not okay. Continuous sound is coming.
Okay, I think I use my.
We can't understand what you are explaining on the side.
Let me check.
Sir, is there any fan or something on, or maybe cooler?
Yes,
Yeah, fan is
that
there.
Actually,
does.
that may be the reason due to which we are
Okay, I
getting noise.
slow down the fan.
Yeah, fine, sir, fine.
Now is it okay?
Yes, sir.
Yes, sir, it is okay.
Okay, actually in the online platform there is a lot of
Yeah.
problem.
And many times we don't identify, like we don't get it.
And we have now the very high temperature in our places,
Okay.
so climate is not okay.
Yes.
Okay. These are some popular algebraic oriented modeling languages. The most popular, the GAMS. It is developed by the World Bank. Developed research center of the World Bank in uh, last, I think, 10 to 20 years ago. And the other competitive platform are AMPL, that is mathematical programming language. Uh, Games and AMPL are almost similar, only their syntax are different, and background their solvers are almost same. And nowadays, the peoples are looking forward the open source platforms, and the Python and the like Julia platform are very popular. So nowadays, one more freeware software, that is Pyomo, that is Python-based open source optimization modeling language. It is also nowadays very popular. It is Python-based platform to solve the optimization problem. But still, it is in developing phase, and it does not have the so many features as compared to the GMS and MPL. GMS nowadays is very developed tool. And is GMS also nowadays used by our system operator like our POSOCO, Power System Operation, or NLDC, National Load Dispatch Center? They are also use this platform to solve their real problems. They solve like their uh, security static only dispatch problem. So now this is the quick introduction, brief introduction of the GMS. It's a high-level modeling system for mathematical programming and optimization. It consists a language compiler and range of associate solver, like a MATLAB also. Like this is a high-level programming language, so it's convert quickly allows to quickly translate the real-world optimization problem in the computer code. Then games compiler can understand, can solve the problem and provide the output. Now, just a minute. Yes. Now, these are like these modeling languages. They have some one platform, and behind they have the solvers. These are the some solvers like Pico, Groby optimization, Ciplex developed by the IBM, Mosaic, Koinur. Then they also feature, we can switch the multiple solver, like same solver have different solver can solve the particular side, like for example LP, linear programming problem. So Ciplex can solve, and other software can solver can solve, so user can switch the solver, and the solver have the different algorithms. And nowadays they are also games also interface with the open source solver, like a Koinu. This is open source solver. So there is the, if you you can download the demo version of the games, and you can use the trial version of the solver, and open source solver you can use to solve your problem. but there are some limitation of the variables and constant. I think is 100 variables you can allow in the demo version. Now, how we can download the games? Go to its official website, gams.com, and depending on whatever you have the operating system, according to you can choose the version of the games and download and install. If you if you download and install the games, there are two options. One option is the games studio, and another one is the games. Uh, it's a games platform. I think in the game site or the basic version. There are two options. So this is the basic version, not a games studio. Games studio, some additional features are there, but the programming or coding syntax it is same. It's nothing changed. Only the layout is different. So this is the basic version. So you can download the game site, and if you comfortable, you can also download the games studio nowadays. So if you download and install the games, then this is simple, very simple layout. Like a MATLAB or other software, it's another different like a layout, but it's a very simple. Very minimum features are there, like file, open new file to write a game code. Here the .gms, it's extension for your coding file. Then very simple option, save option. This is you can see run option is there, print and match the parentheses, find some very small features are there. So this is the simple layout of the games. Then if you download and install the only demo version, so now you can also check our software is a demo version or you have some license. If you suppose you purchase the game software and install the license file, so you can check the license file is copied or not. So go to the help, click on the about, then this window will be appear, or in the bottom you can see the license information. There are some license code is there, it means the license is copied. Otherwise, if your demo version, this part. Now, you can also choose, like in the games, if you want to purchase the games, then you purchase the common platform, that is the separate part. And according to your requirement, you can choose the multiple solvers. And the price and the cost of the software, it is vary depending on how many solvers you want to purchase. So you can choose the list of solvers, and suppose you purchase the AMPL solver, like a Connaught solver, Simplex solver. So in just open, go to the file menu, go to the option, then this type of the window will be appear. And you can see here, there are the different type of solvers and their license. You can also cross verify your selected solvers are installed or not. So you can check they have the full version. Then in this row, first row, you can see there are different type of the problem. For example, like LP means the linear programming problem, MCP the mixed complementary problem, MINLP, MIP mixed, MIQCP, MPEC mathematical program with equilibrium constant, NLP quantity programming. So these are the type of the problems, and they are the solvers. And you can see here the some there are some blank and some dot and dash is there. So dot means this type of the solver can able to solve this particular type of the problem. If there is a blank, it means it is not able to solve this type of the problem. For example, you can see the Ciplex can solve the LP problem, but it cannot be solved the NLP problem. You can see LMP column, a row column, you can see it's a blank. So you can see when you solve the problem, formulate the problem. So according to the type of the problem, you can choose the particular solver. Or if you're not choosing particular, so by default it automatically choose depending on your type of the problem. Now, so this is the already I mentioned. Yeah, for the demo license, these are some limitations. You can linear models, you can generate and store up to the 2000 constraint and 2000 variables. Other type of the models, you have the 100 constant and 1000 constant and 1000 variables. Just a minute. Okay, sorry for the interruption. So these are some limitation of the demo license. Now, what is the format of the games program? So there are three parts. The first one is the input file, that is obviously .gms file. In this input file, we can enter our our code in predefined syntax or predefined sequence also. If they like compared to MATLAB, there are no particular sequence, but here sequence is also predefined. Then the program come to the games compiler. Then games compiler with the properly interface with the game solver. They consider the multiple type of the solvers, so they can program after this code is go to the games compiler and solve by the game solver and get the output again written back to the output, and we get the output in the different it generate the output file. So here the output file it generate .lst file. I'll discuss what is the lst file. And there are the in this lst file there are also fixed sequence. First we create the echo print of our same code, then the reference map, equation listing, variable listing, status report, and results only it provide the variables, what are the optimal value of the variable in we get code in the result part. Now there are some general characteristic of the games. As similar, it's a collection of the statement. Yeah, this is important. Again, the game's average statement is terminated with the semicolon. But here, every section is ended by the semicolon. Like the set, we can define all the set, then it ended by the semicolon. No need to end every set or every statement by the semicolon. One section we can end by the semicolon. Again, important thing, it's not a case sensitive. So if you define the uppercase and lower letter, both are the same. Yes. Yeah, for the comment, like in the MATLAB, we are using the comment for the percentage sign. But here, for the if you want to comment any statement, you use the star sign. And if you want to make the convert in the multiple statement at the same time, so we can write the $on text before that these statement and $off text after these statements. And if you run the code and there are some error, so there are the error statement will be showing with the 4 stars and with particular error number, or like some compiler error, so it's showed by the $sign. So these are the some general characteristic of the games. Now okay, now there are the multiple games statements are there, so they can we can classify in the two categories. First one is the declaration or definition statement, another one the execution statement. These things I'll discuss in the later, no issue. Yeah, as I said earlier, games have the particular predefined sequence also. Like in MATLAB, we cannot be defined like anywhere we can define any statement, but here there is a fixed sequence also. So first of all, in this games, we enter the data part. So we define the set, we enter the data in terms of the parameters, in terms of the scalar and the tables. Then we develop the model including the variables, declaration, equation declaration, equation definition, model definition. Then last part is the solver part or the source statement. So this is the organization of the game's code. Input data, model statement, and the solution. It's a predefined sequence. Now, one more important feature of the games, we can develop like different models for the different set of equations. Like in a power system, we can develop one base model, then we can do some additionals, we can add some more constant and more variables. Then like another software, we have to define write a different code or different file. But here for the same set of the equations or like a same code, we can develop the multiple models for the comparative analysis also. For example, suppose your model have the 4 equations, equation 1, equation 2. Sorry, your code have the 4 equations, equation 1, 2 to equation 4. Now we can define the multiple model like equation 1 and all 4 equation in the model 1. Only equation 2, 3 and 4 in the equation 2 and 3 in the model 2, and equation 2, 3, 4 in the model 3. So same set of the equation we can define the model, or this is very useful feature. Suppose like for economic load dispatch problem, I can develop one more code without the loss and with losses. So only one equation is the change, one or two equations are changed. So same code we can run for simultaneously, we can run for the without loss and with loss, and we can generate a comparative state, comparative sheet also. So we can do the proper result analysis. So this is very important feature of the games. Now come to the coding part. So we have to learn how to learn some basic syntax, how we can develop a games model. So we have to learn some basic syntax, or there is a fixed sequence. So first of all, we define the set or index. Set or index may be the character set, or maybe the number integer set. Any set you can define. So like for example, we define the set as its elements are A, B, C, and D. So how we can write in the game? So simply type set, then define the name of the set, that is the as, then their values. We can also write their name also. What is the meaning of the as? We can write here. Then we can write the element. So we can use the slash, their element A, B, C, and D. Again, we can put the slash to add the set. So this is the syntax. Now, suppose we have the like a multiple set. For example, we have the time period 1 to 24 times. We have the number of generator 1 to 10 or 1 to 100. So we can define like this one. Set T, time period. So we can define T1 start to 24. So by default increment by the 1. So T1 to T24. No need to write T1, T2, T3, T4. Simply write here. Write like this. Or you can simply type 1 to 24. And similar for the generator. And also we can define the character set. So this is very important, because like a real power system problem or bus system, we are not defined like generator G1, G2, G3 or generator 1 to 3. They defined as their names. Like this is the particular thermal power plant, this is the particular hydro power plant. So their location name is there, or the name of the plant is there. So we can define like this one according to their names. Then like similar for the buses, we can define. Now in the games also, sometimes we have to use the duplicate name also. So for the duplicate, they have the same element, but the names are only different. So for that one, we can use the alias statement, alias I comma j or j comma I. So I and j both are the same, only name is different, elements are same. So we can define like this. In the games also, we can define the subset also. So in the subset, for example, we have the defined set I that include the all, that is represent the all sectors. So there are 4 sectors: industrial, light industry, food and agriculture, heavy industry, and services. Now we can create a 2 subset. So this is T comma I, traded sector, light industry, food, agriculture. So they are traded sector. So among these, from these 4, we can define one more set, add the 3 that include the traded sector, and that is and comma, it's not and T comma I, it's a typo mistake, and T bracket I. So non-traded sector is only services. So we can create 2 subset also. So this is the syntax for to enter the set in a games, this software. Now second part, once you enter all the sets, then we come to the data entry part section. In the data entry, there are data we can enter in the 3 form: the scalar, parameter, and the tables. Scalar, if you have the only single value, so we can enter as a scalar. If you have the like a one single column or the row vector, so we can enter as a like a parameter. And you have the 2-dimensional data or the more multiple dimension data, so then we can enter as a form of the tables. So for example of the like how we suppose we have the system demand that is 120 megawatt. So how we can enter, like we type scalar This is the user-defined notation, PD. I defined, you can define any name, A, B, C, anything. So PD, this is a description. The blue part is the description. What is the meaning of the PD? So we can write here the comment here, system demand, and its value. Again, it's by the use the slash 120 slash semicolon. Now, like a parameters, suppose we have the three generator, there P minimum, P maximum, A, B, C parameters. So we have the three generators, G1, G2, G3, and their minimum power. So we can write P minimum, yeah, again is a defined notation, bracket for the SAT, minimum power of generator, G1, G2, G3, same value, so 10, 10 you can write. Similar, this is syntax to enter the parameters. Now, suppose you have the two-dimensional data like a loss coefficient, B coefficient matrix for three-bus system. So like bus 1, I1, I2, I3, I1, I2, I3, and I comma I or I comma J, multiple or any set we have. So we can enter like this one. Or suppose in the real power system, we have the very large data, not the very smaller, small values. So we can directly, we can import the data from the Excel sheet, or you can, for the CSV file or the text file, you can import the data. No need to define all the values in the your GAMS code. You simply import the data. Now, this part is over. First, we define the set, then we enter the data in the different form, or we can import the data from the Excel file. Then come to the next part. Now we are defining the variables. Variables means the that variable we want to optimize. So in the variables, like depending on the type of the variable, for example, there are different types you can see here. If the variable is a free variable, then their default by default the type is the continuous, and their default bounds are minus infinity to plus infinity. If the positive variable, then 0 to plus infinity, negative variable minus infinity to 0, binary 0, 1, or integer, some different values. So how we can define? Simply type the variables, your user defined name of the variable, like for example TC, the total cost, the description. And if you declare the positive variable, like for example in the economic load dispatch problem, the schedule generation is not a negative, it's always positive, so we can define as a positive variable. So PG for the G generator, G already with G the set we already defined, G1, G2, G3. Now here we can also we can bound the variables in a constant also, or directly we can bound here. So if you not want to in the constant, you can simply bound here. So how we can put the lower and upper limits? So this is the some attributes, like for the lower limit we can type PG same dot LO for G1 generator, that is equals to 10. It means the lower limit of the G1 generator is 10, and upper limit, so PG dot up for the upper limit for the set G1 generator, that is 85 maximum value, minimum or max, P max or P minimum. We can define like this. In a power system also, sometimes we have to fix the variable. We cannot be optimized the value. It is fixed value. For example, in the load flow analysis or the power flow analysis, we are fixing the parameter of the slack bus. For the voltage and angle, our slack bus is the fix. So if you want to fix the particular value of the particular bus, particular variable, so we can use the .fx attribute. So for example, dial is the angle, .fx for the bus number 1, that is a slack bus, equals to 0. Angle is the 0. So we can use the .fx. Now two more attributes are there, that is .al and .am. If you solve the problem, then it generates the output file. In that output file, .al is the level value, or this .al is the optimal value. So this is our requirement. .al value is our solution. So we check only this one, .al. And the marginal value, it's used like for the pricing and the shadow variable. So this is the marginal value. So the GAMS file, it's a dual variable of the each and every constraint, and the GAMS automatically showed what are the marginal value of the each variables or the each equation. So that variable is used to obtain the prices. I'll discuss later this. So that is the marginal value. We looking forward for only the global values. Okay, so this is the how we can enter the variables. If the binary variables, you type only the binary variable. Negative variable, type negative variable. Very simple. Now, the next part. Once first you enter, first define the set, then enter the data, then define the variables. Now we come to the next part, that is equations. So to write the equation in the GAMS, there are two parts. First part is the equation declaration, and another part is the equation definitions. In equation declaration, we just give the name of the equations. For example, we have these two equations. I think as electrical background people, they are very comfortable with these two equations. So this is objective function to minimize the total cost and the system demand. Generation should be equal to system demand. So suppose we want to write these two equations in the GAMS. So first give them first we give their names only. So type the equations, give the names, objective function, supply and demand, or their, this is the blue part is their description. What is the meaning of this one? And again, it's user defined. You can write simple equation 1, equation 2, anything you can define. But we have to give the proper name for these equations. So this part is known as the equation declaration. Now we are defining the equation. So second part is equation definitions. So now what is the this mathematical formulation? So we just type again the same name, objective function. Then we type that these two dots. It's a compulsory syntax. It means this equation is on here. So again, type same objective function, two dots, same DC variable we already defined, equal to, I'll discuss here. Then sum set I, same as like this one, AI, BI, and CI. You can multiply it by the same repeat, or you can use the SQR square term, or you can use the double star 2. I think I just mentioned, but just a minute. For the power, you can write like this one, or you can write like double star 2 for the power. Now, same for this equation. Now you can see in the when you write the equation, so that equal to, greater than equal to, less than equal to, they are not simply write like equal to sign, greater than, and the last one. Here we are like this different syntax is there. Suppose you want to equal to, the equal to sign is there. So only this is applicable for the only equations, not in the variable or the not in the parameter calculation. And then parameter directly you can do the equal to sign, greater than, less than, or condition also you can do directly greater than, equal to, less than. But in the equation, it's predefined syntax. So equal to sign we can write like this one: greater than equal to sign, G for greater than, again equal to sign, less than equal to L, again equal to sign. One more problem is there sometime in the GAMS. You understand this is this is the 1, or sometime you confuse this is L is not, it's I. So to avoid this confusion, always I recommend all use the capital sign, capital letter. So you define capital L. So that sometimes it creates the error in the code, because by mistake the people write the 1 or I, so it produces the error. So to avoid this type of the error, always use the capital letter, because GAMS is it's not a case sensitive software, so you can either use the capital or small letter. So mostly for this one, use the capital letter. So these are the some type: greater than, equal to, less than, equal to. If the no relation, it's very rarely used. So you can, and for the no relation. So this is the syntax how we can define the equation, or how we can write. Now, once you write all the equations, then we can come to the next two part, the model and the solve statement. So in model, we compile all these equations. Suppose our particular model have considered all these equations. So first we write the model type. The syntax is that type the model name and slash all. All means this model considers all equations. If you want to specify the number of particular equation, the particular model, then instead to write the all, you can write their names. For example, suppose my model, I define the model. The name is economic load dispatch. Again, it's user defined name slash all. So it considers all these two equations. But suppose I want to include only the equation number 1 in this model. So instead of the all, I write the name objective function. Or suppose equation 1 in this model, so I type the, or instead of the all, I type the only equation 1 or equation 2 and so on. Now, once you write this model statement, we can compile all the equation in the particular model. Then we come to the last statement, that is called the solve statement. Now, up to this, at this statement, our model is compiled in this particular model, and it goes to the solver. And solver they can solve this our model and provide the output. So how we can write the solve statement? This is the syntax. Type the solve, model name, model type, depending on your LP problem, NLP, MIP, uniformity problem. So you know what is the type of the problem. Then the direction, maximizing or minimizing. Then objective function variable name. So same another syntax is there, and either any syntax you can use. For example, here I write the solve, model name economic load dispatch, using my problem is NLP, so I type the NLP. Direction is the minimizing the total cost, and objective function variable. One more important thing that you should be remember during writing this, defining the like model statement, our objective function variable should always be defined as a free variable. Like simple variable you have to type. It's not a positive variable or negative variable or binary variable. It always be the free, very continuous variable. So variable TC, like simple variable. If you define the positive variable as the objective function variable, then it produces the error. So now this is the last one. How we can type this one. There are the different model types, LP, MIP. They are short form. You can also check on the it's a solution. It's a user guide, user manual. You can also check what are the abbreviation of this different type of the problem. So this is the last one. So you can see in the GAMS, to solve the particular optimization problem, first we define the set, then enter the data, define the variables, define the equations, type the mathematical formation of the equation, then type the model and the solve statement. Very simple, 5 and 6 steps are there to write the code. Okay, let me consider the general optimization problem. There are some 10 objective function, some constant, equality constant, and then inequality constant. And there are different type of the, depending on mathematical relation between the variables, there are different types. Okay, now let me consider the very simple problem, not from the electrical engineering background. It's a very simple problem. Suppose a boy has the 10 rupees to spend to purchase the apple and oranges, and if you spend every rupees to purchase the apple, it will be get the 2 unit of the happiness, and for the each oranges it give the 3 unit of the happiness, and its goal to optimize or maximize their happiness. Very simple. If boy have the 10 rupees and he want to spend the 10 rupees to purchase the apple and oranges, but we define some criteria. If you purchase the apple, then it get the 2 unit of the happiness. If you purchase the orange, then it gives the 3 unit of the happiness. And its goal is to maximize their happiness. So how we can formulate this problem as the optimization? How much amount of the rupees that you want to purchase the apple and oranges? So we can define the objective. Obviously, it's a maximization problem, so we can define the maximization. And how much amount of the rupees to be spent to purchase the apple and orange. So we can define variables. So we can define XA. It's a variable, how much amount of the rupees to spend to purchase the apple, and same for the oranges. So define XA and XO, or you can define X1 and X2. Then define the objective function. We can see the weightage is given. 2 rupees purchase the apple, the two units of happiness. So we can define the weightage 2. For the 3 units, so we can define the weightage of 3. So this is our objective function. Then come to the constant. Our total money is the 10 rupees. So summation of this XA and XO, that should be less than equal to 10. And another constants are our variables is not a negative variable. Rupees are not negative. So both the XA and XO are the positive variables. So we can define they are the greater than equals to 0. So very simple problem, like simple LP problem. And if you solve, you can solve this problem by using the graphical method. So we can check, you can see, we can vary the value. You can see there are two optimal point. When XO and XA is a 0, XO is a 10. So one optimal point is a 0, 10, and another one is 10, 0. So this is the feasible reason where we got the solution. I think if you study the operation research, so you know what is the graphical method to solve the LP problems. Now, how we can solve the same problem by using the games, or for this one, I think without solving, we know the solution. What is the solution? We want to maximize the value. So obviously, the weightage of the XO is more as compared to XA. So if you spend the XA for the 10, so you can see the 30 value. You can see without solving, you directly know the solution. You can see XO is the maximum value, the 10. Then you got the this objective function 30. And if the maximum XA, you can see here 10, so you can 20. Or in between, you can vary the maximum value to 30. So obviously, our solution is the 0 and 10. That is the maximum value. Now, we can solve the same problem by using the games. So here, you can see there are only very two variables are there, no multiple variables. So no need to define the set, or data also, there is no data. Very simple. So directly we come to the start with the third part, variables declaration. We skip the first set and data part, because very simple problem, no need to enter the data. So directly we come to the variable part. So just type the variable, then we can define the objective function here. This one we can write like a Z. This part we can define like a Z. So Z objective variables that to be maximized. Then positive variable we defined XA and XO. So no need to write these two as a constraint. Already we defined as a positive variable, so no need to write in equations. Then equations, there are two equations only. One equation number 1 is objective function, and this is equation number 2, it's an inequality constant. So only two equations we have to write. So we can type the equations, simply type the equations. First we define these positive variables. The blue part is their description. Then we type the equation names, objective function, inequality constant, or you can simply type the equation 1 and the equation 2. Then we type their mathematical, this section, each section you can see, each section we are terminated by the semicolon. Not every statement we require to write semicolon, it's not required. Only end of the section we write the semicolon. But for the equation, each equation, mathematical equation, it should be terminated by the semicolon. So again, we type the objective function, same name, type the two dots, Z equal to sign, same. You can see 2XA plus 3XO. inequality constant xa plus xo less than equal to 10. Right? Simple. Then we type the model statement, model, user defined name, example 1, all consider all two equations. Then we type the solve statement, solve example 1, using type of the problem is the LP, direction is the maximizing, objective function variable is the Z. Very simple. So this is the code for this to solve by this to solve this problem. Now, if you run, click on the run icon. Then it generates the two files. One file, just I directly show you. Suppose I increase the font size also. I define the variable Z. Okay, is it visible? Or I'll increase again more font size. This is fine. Okay, the font size is okay. So just type the variables Z. Type the positive variable. XA and XO. Then type the equations. Equation 1, name only. Equation 2, then their definitions. Equation 1, 2 dots, 2 XA plus 3 into XO. It equal to the model statement. Equations. Yes, done. Now you can click on the run icon. You can see run. Yes, you can see. Here one open is the one window is open. It shows the summary of like it is solved by the simplex, reading the data, summary of the process. Then it shows the LP status, optimal value. It shows the time for the solver time, simplex. optimal solution found. The value of the objective function is obviously you can see 30. And it generate also the one LST file. In LST file, you can see first it show the equation listing, same. I'll show you. Yeah, you can see it show again the same our code with their line numbers, computational time, show the equation listing. These are the equations, left hand side and RSS side. They are feasible, so there are no error. So if there are, therefore star sign is there, and it's also show the infeasible. Then variables, the upper and lower bounds. Then their model statics. You can see number of block of equations 2, single equation 2, block of the variables 3, non-zero elements 5, computational time. Then solve summary is show the model name, example 1, objective Z, type is LP, direction is maximize, solver it is used by the Ciplex. We write the solver estimate at the line number 60. So from the line 16, solver status is the 1, normal completion, model status is the 1, optimal value, objective function variable value is 30, Z is 30. Resources limits, you can see there are by default limit, iteration count, you can see. Then, yes, if you click on the solver also, you can see the only the variables. So you click on the Z, you can come to the here. You can see it show the variable Z. We define Z as a free variable. So their lower bound, lower value is the minus infinity, and upper value is the plus infinity, and their level value, that is the optimal value, that is 30. Variable X, say lower limit is a 0. GAMS by default, instead of the 0, it show the dot. Dot means the 0. So value is the 10. So our optimal value for this problem is the SA is the 0, SO is the 10, and our objective function is 30. Then it's so non-optimal 0, feasible 0, unbounded 0, their license information, file input, out file summary. So this is about the output file. Yes, same thing I already explained. Yes, you can see we are the model statement, we got this first one, optimal value, that is desirable also. For the LP problem, there is no issue of the global and local optima, only we got the global optima solution. But in case if you are using your problem is an LP type or other than LP, then you also get the local optimal or global optimal solution. So if you use the local optima solver, then you get the local optima. Use the global optima solver, you get the global optima solution. So it's the model status 2, it show the local optimal solution, 3 unbounded solution, 4 infeasible, locally feasible, infeasible, incomplete solution. So these are the other model statement, but our requirement is the first one. Then solid statement, solid status requirement is the 1, normal completion. 2, sometimes the problem is not solvers fail to converge, so it will be interrupted. So the second is the iteration interrupt, resource interrupt committed by the solvers, errors, capacity problem, licensing problem, user interrupt. These are the different other status of the solver. We required first and first. Now, similar to other programming language, games also have like a conditional statement. We can apply the loop statement. If an like a for loop, you can use repeat loop. We can use here loop, while, and repeat. For we can also use here. So loop statement and control statement also here. The games also. Okay, I quickly discuss this one. I think it's not about this. Yeah. Suppose we want to repeat the same problem for the different value of the money. Suppose we have the 10 rupees, 20, 30, and 40. So we have to only repeat the same problem for these different values. So for this one, there are two methods. We can use the like a loop statement, or we can define like a set. We repeat the same problem by using the set. So we can define the set, that is total number of the money, 1 to 4. We can enter as a parameter the value of the money is the I1, I2, I3, I4, 10, 20, 30, and 40. Then we only modify the inequality constant. Now earlier inequality constant xa plus xo is less than equal to 10, but instead of 10 now we are write this r, this parameter r into I. So you repeat this one, you get the same, you get the value, you got the result for the different value. Or just I show the example also. Suppose I want to repeat, so I can define the set I can define 1 to 4. Then I enter the data, rupees for r bracket I. 1 is 10, 2 is the 20, 3 is 30, 4 is 50. Now I change only this one. Okay, it shows only the last one result only. Okay, I can store the result. Store the result, I can define. I can store the XA value, XA.L, XO, and we can display. XO is 10, 10, 10, 10. Okay, it's not very changing. Okay, we have to change also. Their values are different. So we have to set define also there. Okay, dimension different. Yes, now you can see solver statement. You can see XA is 0, 0, 0, 4, 15, and XO is 10, 10, 10. This one. Okay. So depending on your weightage also, or you can also define their cost also, like it's a 2 rupees cost for the oranges, and your result will be different. So this is the one method you can repeat, like you can define the set for the variable. So you can see now there are 4 times the 4 different value, it will be the 4 different by using the set we can obtain the different value. Or if you repeat this one for the loop statement also, so that one is the like this one. I define the loop I replace the R with the Ri, different value, solve this one and store the value in the different parameter like a report. Now yes. Now the next part is the that is very important part. For the practical system, we have the very large set of the data set. So it's very difficult to write like in the simply the GAMS compiler. So we can import and export, import the data from the Excel, and we can export our result in the Excel file. So for that one, in the GAMS, it's GAMS data file. It's the .gdx file. Like we know the every software have their own data set, the syntax for every data set file. So here that is the GAMS data access file. So if you import or export the data from Excel to GMS or GMS to Excel, first the GAMS, suppose GAMS to Excel. So the output of the like the variables, first we convert in the store the GDX file, then GDX file is converted to the Excel file, and opposite reverse for the Excel to GMS. First the Excel data is come to the GDX file, then GDX file is read by the GAMS. So how what are the syntax for this one? Suppose we want to store our result XA, XM, their level values, or like our results file in a you want to export to the GAMS, sorry Excel. So we can write the statement execute unload. Name of the GDX file, results.gdx. And in GDX file, we store these variables, their level values. Then we execute this utility gdx xrw.exe. Result same gdx file, results.gdx. Output file is the user defined name. You can change the name. Results.xls and variable name xo.l, or in the parameter, then you can type the parameter here. Then you can see when you run the code, this same file will be created in your same directory, games directory. I'll show you that you can see. Suppose I want to export this result in the game in Excel file, so I can write execute. I can create one GDX file like results1. In this, I store the results. And same file. This is the range list. It's the name of the Excel tab. So I just type RX1, example1. Okay. Okay. It also shows, you can see, call GDX XRW, input file and output file. And you can see here also, it create one GDX file. Let's check the, yes, you can see. It create one GDX file. Their values is stored here in GDX. Now, same file you can see in, go to the documents and games dir, game directory, project dir, you can see results1 file. You can see the Excel file tab user given RE example1, set 1 to 4, XA and XO values. Very easy. You can see we export the result in the Excel file. Okay. Yes. Now, similarly, if you want to import the data from Excel to GAMS, for example, suppose we have this data set. We have the 6 number of the generators, the P minimum, P maximum, A, B, C values are there. Suppose this is given the Excel. So in Excel to GAMS, so first we define the set I 1 to 6, same as given in the Excel sheet. Parameters, we can define parameter name G data I star, because their first row, you can see their parameter names are different, not same. So they are different, or as a games they are different set. So we use the star sign. Otherwise, suppose here 1 to 6 is there, so we can directly use I comma I if we have the same set. Then again, then we call the GDX SRW, name of the Excel file, parameter name same, range we can give the where the data is stored in the Excel file, seat name by default the seat 1, start from the A1 If you own the different location, like from the data start from the C1, D1, or any location or any row or any column. So as they write their according, we have to write their name. That dimension by default generally there's two-dimensional data. So the row dimension, column dimension are by default 1 and 1. If three-dimensional data, then their dimensions are different. Then we type the $GDX in RI, same GDX file name .gdx. This statement create the Excel to GDX file. So again, we read the GDX file here, then load from GDX file, we can load the data of RI, GDX in, and display. To display the data, you can use the display statement. So this is the syntax how we can read the data from the Excel file. Or like one more important thing. Suppose in the very large complex program, suppose multiple time you have to read the data from the Excel file. So it's a time consuming. So to avoid this time consuming, we can create one like a include file. We can create the include file in the GAMS. So only one time we can read the data. Then if you want to rerun the program, no need to again all this data from the Excel file. We can directly call the include files. For example, I have one data set, so I'll show you. Yes, like you can see here, I read this parameter from this Excel file. Then we can create this one include file. Include same name, startup as well.inc. So next time, if your repetition, you can repeat the repetition of the code, rerun the code. Then no need to call this one. We can make the commit. This file we can make as a commit, and then only we read the data from the include file. So it will be save the time, save the execution time. Now we have come to the error debugging section. Now there are syntax error only, but sometimes you can understand what are the most common error. So like sometimes we forget to closing the parenthesis, like it are missing, so it create the number of the 8. We are missing the 2 dots in the equations, then this will be error. Equation type, we are forget to write the dot L. Instead of the L, we type the 1, or we can type the I. So this error will become error number 37. No-linear expression prohibited, so it's 51 to 60. Data items, it not give the numerical value of the equations. 71 equation has been declared but not defined. It means equation name is the given, but their mathematical equation mathematical formula is not defined. So error number 71 will become appear. Now this one statement followed by the another statement is not terminated by the semicolon. In the equation, every statement should be terminated by the semicolon. If you forget to write the semicolon, this error number 96 or 97 will become. Typo errors without quotes 120. SAT is controlled 125. Keyword is declared but cannot find it. So these are some common errors. duplicate of the name. Mostly syntax error are there. Yeah. So this is the error debugging part. Suppose you forget to define the objective function as a free variable. Then if you define like a positive variable or negative variable, or you bound the it should be free unbounded variable. If you bound the objective function variable, then it will be create the error. So the right way, the positive objective function should always be defined as a free variable. Yeah. One more, if you enter the data in the games file directly, not importing from the Excel. So your table column should be properly aligned. If like it's not properly aligned, like the floating entries, you can see, so it will create the error. Again, it will show the error. So that should be properly aligned. Yeah, it is also important. Sometime like it show the error uncontrolled set enter as a constant. For example, if you write in equation declaration, you write the equation constant bracket I, or I, you can see the control, or you forget to type bracket I here in the equation definition declaration, then it shows the error. So this is the right way. We can also, if the set you are using here, there are 4 times, so we can define this equation repeat for the 4 times. So we have to define the set here also. If you forget to write here, then it will show the error. So these are some common example of the error debugging. Now this is for your own practice. Suppose this is a linear problem, 2 variable x1 and x2, set of constraint. Then we can solve by using the graphical method, find out the optimal values, which one are the most optimal. Then put in the optimal value in the objective function, find out the minimum value. Or you can solve the same problem by using the games. So if you write the code for this one, you will get this. This is the answer. All participant, do you have the game software demo version? Hello.
No, sir. We have to download it.
Okay. So you can download. I saved this PPT, so you can download and just write to simple code for these problems.
How can we get PPT?
Yeah, I'll save this PPT. So I'll save this PPT after this session.
Is it similar?
Okay, thank you.
Sir, is it similar to
you can
MATLAB?
Download the demo. No, it's not similar to MATLAB.
Not similar.
It's completely different.
Okay.
Or it is for the optimization, it's easier as compared to the MATLAB. You can see in the MATLAB, you have to define this equation, you have to enter the equation in the matrix form. Or if you use the optimization tool of the MATLAB, so for the simple problem you can do it, but it's for the larger problem it's very difficult. But here you can see as your mathematical equation seems very simple. As what is your equation, as similar you can enter in the games. I defined this XA, so I just enter the XA. It's very simple format. So it's for the optimization, it's very easy and as compared to MATLAB. And its solution is also authenticated because we cannot be change the solver code. Solver codes are fixed. They are coded by some reputed organization like IBM or some other organization, or they already tested that their solver efficacy for a large number of the mathematical problem. They claim the particular accuracy for the solution. So no need to so their solutions are authenticated to show the optimal values. So for the as in my experience, for the optimization, it's a very good tool, and it's crowds of variable it can handle. So very large problem you can model here and you can solve. There is no limitation for the number of the variables also. Very large number of variables you can define. So by using this software, the researcher or the people can more focus on the modeling part instead of the solution, how we can solve it. Like some people are using the PSO, GA, genetic algorithms. So they have to write the codes also. Or like they are putting the sample population, then define set of rules and get the solution. So these are some behind how the conventional algorithm also. And each solver have their own their solver manual. So if you want to detail study about which method they are using, what are their accuracy, so you can read the solver manual. That is available on the games as well as the internet. So my game section is over here. Some examples also here. So for your own practice, if in the second session I have the time, so I can do one more example here. I share this PPT.
Hello, sir.
You can go through some. Yes.
I have some questions.
Yeah, please ask.
We have a data having in terms of, we are taking MRI. We are taking MRI from the meter. We are using having that data in CSV and MRD file. We have an Excel file. Can we model this in this text, or can you model this data in the GAMS software? We have import.
Can you repeat your?
We have import and export in MWH. We have
no. It's games. Games nowadays comfortable. So you asking about the how this data import about the data import.
No, we have an Excel file. You told that in Excel.
Yeah, Excel file.
Yes,
you can.
We have an Excel file.
Easily you can import.
Right. Can you model this in this game software and get data? We have that MW export and import from the transformers and line. LV and HV side.
Games particularly, games particularly used for the optimization purpose only. Any problem, if you have some objective function and some constraint, whatever your type of the problem, that is not the issue. But optimization problem, it can be solved. For your problem, if you have some optimization problem like you are optimizing any weight or anything, your objective and constraint, then you can solve it using this software.
But can we synchronize this directly from Excel file?
Yeah, it's synchronized. Automatically read the data and export. It's easily automatically read and export. Or you can also synchronize this games with the Python and MATLAB also.
Okay.
So your data in the MATLAB, your data in the Python, your remaining code in the Python, only optimization you can do in the games. In the background also, no need to open the games. But for that purpose, you have to write like interface code for the games and the MATLAB also, like Python.
How we can model?
Or some.
My question is that how we can model if I want to optimize the grid failure of the grid failure, which is the parameter of. Nowadays, frequently grids are failure.
Grids are failure, so you want to optimize this problem. If you want to go to the stability problem, or any reliability problem.
Reliability problem, related to the reliability problem.
Yeah, so the reliability problem, I think you go for the literature. How they mathematically model. If you either you can do your own modeling. First, like in this platform for the only this is the not a particularly for the design for the power system or electrical engineering. It's a general platform to solve any optimization problem.
In terms of economical, in terms of money, compare.
Any problem, any field optimization problem you can
Thank you.
use.
I think we should stop here, sir, and then we will again meet around 11 or 10:45, sir.
10:45 we can meet.
Uh, okay,
10:50 you can.
okay, 10:50. So
Yeah.
all participants are requested to join on the same link around 10:50. Okay.
Okay, thank you.